Get started. So I want to welcome everybody today to our first ever virtual, or I should say QuaranTEEN virtual science cafe. For those of you who are new to Zoom or doing things in a virtual space, we just want to go over some protocols that we're going to have for today's gathering. We are asking that everyone stay muted throughout the presentation. It's just going to be more manageable that way with so many people on the line. And also it prevents any background noise or interruptions. So we're going to ask that you use both the chat box and the Q&A box today. And the difference between those boxes, and you can find both if you hover over your toolbar at the bottom of your screen, you'll see those. For the Q&A box, we're going to limit the Q&A box just for questions you have related to today's presentation, specifically to what the presenters talk about. And feel free to ask your questions throughout the presentation. Although we may not get to your questions till the end, they will be queued up in the Q&A box. So when you think of something, go to the Q&A box and type your question. The chat box is really just for you to share your thoughts. If there's any technical issues that come up that you need to tell us about. And if the presenters ask you to think about something and share ideas, you would do that in the chat box. So we're really going to distinguish those two features today. We're going to ask that you be both courteous and respectful to not only our presenters, but also other attendees today. And make sure that you don't create any distractions. We don't want you making silly faces at each other, or be aware of what's going on in the background. I don't think anybody's screens show up. I can only see the presenters, but in this virtual space, we want to keep any distractions to a minimum. And then we just ask, please just stay engaged and participate fully, because I know our presenters have a really engaging presentation for you today. So I want to welcome our presenters today. Today we have the Lake Champlain Sea Grant Education Team. They work on a project called the Watershed Alliance, which serves K-12 teachers in Vermont in the western portion of the Lake Champlain Basin. Through this program, staff engage students in research happening at the University of Vermont and the State University of New York at Plattsburgh through their water quality laboratories. The UVM Extension Watershed Alliance program operates from the Rubenstein Ecosystem Science Laboratory on the Burlington waterfront and is home to one of our presenters, Ashley Eaton, who is the Watershed and Lake Education Coordinator. She holds a Master's of Science in Natural Resources and is a true stream monitoring enthusiast. We also have with us today Caroline Blake. She's the Watershed and Lake Education Program Assistant who holds a Master's of Science in Natural Resource and is a believer of Benthics. And then leading the New York branch of the Watershed Alliance program stationed at the Lake Champlain Research Institute in Plattsburgh, New York, is Nate Chokji, New York Education Specialist who holds a Master's of Education in Environmental Education, and he is a self-diagnosed nature nerd. So we are excited to have you all join us for our first ever virtual science cafe. And at this time, I'm going to turn the screen over to our presenters.
Great, this is Caroline. I'm just going to switch my screen so that you all get to see our PowerPoint. I'm going to go to present mode. All right, and then I'm going to pass the floor over to Nate.
Thanks, Caroline, and thanks, Lauren, for that introduction. And welcome, everyone. I'm really psyched to have you all with us today. As Caroline gets this presentation loaded up, we're going to get to spend some time together talking about benthics, which is shorthand for benthic macroinvertebrates. And if you've never heard of those before, don't worry. That's the whole reason we have you here today, is to learn a little bit about them together. So slide. A little bit about Watershed Alliance. So basically what Ashley, Caroline, and myself do is we help researchers get their information and their knowledge out into the world and into the general population and to students like you throughout the Lake Champlain Basin. So our program called the Watershed Alliance takes students out of the classroom, into the streams, onto Lake Champlain to learn about our watershed. And we also go into classrooms as well and lead some in-class activities. So maybe we've met some of you before in person. If so, good to see you again. So in a moment, we're gonna watch a video together that we made just the other day. I went out into the field and sampled for benthic macroinvertebrates. So I was in a stream just outside of Saranac, New York, that feeds a small stream called True Brook. True Brook flows into the Saranac River. So what you're seeing right now, that blue pin that's circled in red, is the location I was at sampling. And then True Brook, flowing from left to right on your screen, enters the Saranac River. And then the Saranac River eventually flows into Lake Champlain. So again, that blue pin is just where I was sampling in the stream. And then that red line that you're seeing kind of traces where water will flow from that small tributary into True Brook, into the Saranac River, and then into Lake Champlain. So in just a moment, Ashley is going to put a link into the chat box. And so you can go to the chat, click on the link, watch the video, and then return back here once the video is over, and we're gonna reconvene then. So go ahead, open the chat box, find that link that Ashley sent, click on the link, and then bounce back here. We're gonna give you just a little bit more than 8 minutes to do that, and I will kind of call out to you when we're getting ready to get started, so you know that it's time to come back. Cool. All right, enjoy the video.
Oh, this is a great way to just make sure that you all have better internet connection and we're not trying to restream through the PowerPoint. So this is our way to circumvent, and that way you can open up that link. So like Nate said, enjoy the video. We'll check back in just a little bit.
I do see a message that it's not working for one person. If anyone else can hear, if you're having trouble, Ashley just put up a link again.
Ashley, did that link go to all panelists instead of all attendees?
if you are wondering about the sound, it's nobody's talking during this time. For those back, Ashley just posted, if you could write in the chat, tell us what a favorite part of the video was.
All right, everybody. So Nate is going to do a final timer on things and give us a shout out time-wise.
Yep, so just another minute to finish up the video. I see there's still a handful of folks that are coming back. Remember that video is on YouTube, so you can always go back and watch it again or finish up if you don't have the time to do so now. So just maybe 30 seconds or so, you can all start coming back to the Zoom, and we're gonna move along here.
So while you're all coming back, I'm about to launch our first poll of the series. And so you're going to have a little box pop up, and it's going to have a question in it. And it's going to have some questions about the film you just watched. So you should all start to see this in just a moment.
Great, so you should see that first poll pop up on your screen asking you for the name of the tool. So what was the name of the tool I used in the video to collect benthic macroinvertebrates? Toward the beginning of the video, I explained how to use it and what it was called. So if you remember what it was called, you can tap that answer and then hit submit. So I'm seeing that some folks missed the poll, and that's okay. Ashley's going to share results in just a moment once most folks have answered. I think if maybe you came back a little late, it might not have popped up on your screen. But it looks like most folks got a chance to answer, and most folks got that one right. So the correct answer was kicknet. That's the name of that long net on that big pole that's like almost as tall as I am that I was sticking on the bottom of the stream. That's a pretty common tool used to collect benthic macroinvertebrates.
Hey, Nate, for those that couldn't see the poll, could you read what the question was?
Absolutely. So the question was, what is the name of the tool that we use to collect benthic macroinvertebrates? And the answer is kicknet. So that was that long net that I was using in the video. So maybe we can go ahead and launch that second polling question. So again, it should pop up on your screen. I'm seeing it pop up on mine now. I'll go ahead and read the question out loud for folks. So this one is about safety. What is one important thing we need to consider to stay safe during a stream investigation? So there's a point where I describe sort of some best practices, if you will, when walking in a stream and what you should do. So you can go ahead and answer this poll and then hit submit. So it looks like some folks the poll isn't popping up for, and I apologize for that. It might just be that you have pop-up blocker enabled, but I'll be sure to read through the question and the answers once the results are shared. So I apologize for that, but I think most folks are seeing the poll, but maybe you can just think in your mind of the best answer. Remember back to the part of the video when I was describing how to stay safe when walking through a stream. So you can just kind of think to yourself, what are some things I should be considering when I'm walking through a stream if the poll's not popping up for you?
All right. Hi, everybody. Nate, do we
Oh,
want to share
so
the answer?
yeah, let's share the results before we move forward. So hopefully most folks are seeing the results on their screen. Again, what is one important thing we need to consider to stay safe during a stream investigation? And most folks got it right. Walk slowly, facing upstream and taking small steps. So I put a few silly answers in there. I figured at least one person would try to go for the crawl on all fours to remain multiple points of contact. But that's not what you want to do. You just want to move slowly, take small steps. So yeah, and with that, thanks for answering those polls and participating. Those of you that saw those pop up, and hope you enjoyed the video. And now I'm going to pass it off to Caroline, who's going to talk a little bit about what benthic macroinvertebrates mean. I saw a question in the Q&A about whether they're good or bad, so we're going to start to dive into that a little bit now. Thank you.
Great. So again, my name's Caroline Blake. Lauren did a great job introducing me, but I also thought it was fun to do a more direct correlation of where I am located in the state of Vermont. So I'm actually in the Richmond area. So I saw some people in the chat from Richmond. So love this little town, but let's talk about biological indicators. So we've been using this term, but what does it mean? Well, a biological indicator usually is referred to like a species-wise. And what this means is they're a group of organisms whose presence, absence, or abundance reflect a specific environmental condition. So like in this case, we're looking at water quality. And as scientists, it helps us let us know, is it a healthy ecosystem or not a healthy ecosystem when it comes to water quality? So the word benthic macroinvertebrates, I know Nate in his PowerPoint or his movie told you what those are. For the sake of acronyms, I'm going to use the word BMIs, the rest, but that means benthic macroinvertebrates. The reason scientists love using these for studying water quality, there's many reasons, but as you can see on the list, really the key point is that they spend all of their life, or if not most of their life, in the water. So they're really telling us what's going on in a specific section of a stream. Two, they're really easy to collect. Nate and Ashley and I just said, Nate, can you go to a local stream in your backyard, basically, and can you put the kick net in there, and you can see how easy they are to collect. And then last but not least, each species is really different in how they react to pollution. So we're going to use this term tolerant or intolerant, and I'll explain more in just a second. So when monitoring water quality, I have two pictures here to kind of show what I mean by a healthy or an unhealthy body of water. In the first one, a healthy body of water, we're hoping to see a high variety of BMIs, meaning that they're intolerant to pollution. They cannot survive in polluted water. So you can take a look around, it looks clear, there's habitat, etc. The second picture is demonstrating a polluted body of water. In most cases, you're going to see a low variety of BMIs, or you might not even see any. If you do see some, they're going to be tolerant to pollution, meaning they can survive in a polluted body of water. Here on this screen, I just found kind of this quick graphic to walk you through some of the species that fall into certain groups. This is a very, very basic chart, but I'm going to walk you through each one. So for example, if there were some BMIs that were found in group 1, you can see at the top that it's saying that they have to live in a high quality of water. Some of the species you heard Nate talk about already, but stonefly and mayfly and caddisfly, again, these belong to that group 1, and they like that high quality of water. As for group 2, you can see right here that they can survive in some pollution. So there might be a little bit of pollution in this lake or stream, etc. And these are the species that you might find. Some common names are the Dobson fly or the crayfish. Maybe you've heard of a dragonfly, etc. And then last but not least is this group 3. Group 3, they can survive in polluted water. So again, in a polluted stream, you might see some aquatic worms or maybe midges, etc. Each resource that you're going to see is going to show kind of something similar, but not exactly identical, but I just wanted to give you a visual to understand what species might be in each category. Now for the fun stuff. So Nate, in his lovely video, caught quite a few creatures, and I wanted to walk through. I couldn't do all of them, but I wanted to share at least some fun facts. So the first one that I'm going to talk about is going to be the stonefly, which belongs to the Plecoptera order. If you reference back to the slide right before this, I actually said that they belong to the group 1, which means they're intolerant to pollution. They need lots and lots of oxygen in order to survive. So some fun facts about stoneflies. There were quite a lot to choose from, so I just highlighted a couple. The first fun fact is that there's more than 3,500 different species of stonefly throughout the world. The second fun fact is if you look at this photo right here, this is actually me zooming in on a video clip that Nate took from his video. And if you look at the very tips of their legs, you can actually see some claws. So each leg has 2 claws that help them to grip to rocks in order to hold on in fast flowing water where you're going to find more oxygen. If you go further up the leg, you see kind of these weird string-like things right here. These are actually the gills. So in order for these creatures to breathe underneath the water, they actually breathe through their gills that are located on their legs and even in their armpits. I like this photo right here just because it shows the general size. You know, it's a human finger. They really can be quite tiny, but they can get quite large as well. And they are camouflaged. When Nate flipped over that rock, it took me my eyes a second to actually find that creature on the rock that he was pointing to. And last but not least, these 2 right here, these are actually the aquatic nymphs, meaning that they're spending their time in the water. However, when they fully form into an adult, they're actually going to be a creature that live outside of the water, and I just wanted to include a picture right here. All right, so moving on. The next one I want to talk about is the mayfly. So the mayfly also belongs to that group 1 from that first picture that I showed you, meaning that they're intolerant to pollution. I wanted to highlight a quick clip that we had for some fun facts about them, and it's based on how they move, and it's a really easy way when you're out in a stream to tell what species you're looking at. And so I'm going to click on this link.
How are they moving around in the pan or in the ice cube tray?
So what I wanted to highlight there is that mayflies, when they're moving in the water, they actually move in an M shape. So you actually got to see it almost moving through the water like the shape of an M. Also, these creatures live in very high quality water and they need lots of dissolved oxygen. Just like we as humans, we need oxygen to breathe. So when we use our lungs, that's called atmospheric oxygen, whereas these creatures need to get oxygen through the water. One such way is through their gills, and for a mayfly, their gills are actually located on their back. So I highlighted this photo right here to show you what their gills look like in a zoomed in manner. In all, there's over 2,500 different species of mayflies worldwide. So again, quite a few. So even if you were to look up photos online, you probably wouldn't even find the same species in each photo that you click. And then the last fun fact that I wanted to show is this adult form again. So once the mayflies hatch, a cool fact, there's a couple of them, is that as an adult, they actually don't even have mouth parts. Their sole purpose is to find a mate and to reproduce. So they don't even actually eat. With that being said, they have a tendency to all hatch at the same exact time. Maybe you had the privilege of being in a mayfly hatch and being out on a stream in a canoe or whatever it may be, and you kind of get pelted in the face with these thousands and thousands of mayflies that are flying through the air. This is very common for fly fishermen. If anybody here fly fishes, to have them replicate a fly on the end of their fishing line because fish and trout love mayflies. Moving on to our next species, the Dobson fly. This belongs to that group 2, meaning it's slightly intolerant to pollution. It's not It doesn't have to live in perfectly healthy water, but it needs a balance between polluted and unpolluted. And so with that, some fun facts about them is that it kind of looks like an aquatic version of a centipede. I again zoomed in on one of the photos or the video that Nate had to show you one of the ones that he actually caught. It is the largest aquatic invertebrate in all of the United States. I thought that was a pretty cool fact. It has 3 pairs of legs. You can see 1, 2, 3 pairs of legs, but you might wonder what the other parts are. They're actually called filaments, and there's 8 pairs. So I'll count 1, 2, 3, 4, 5, 6, 7. At the very, very end, there's the 8th pair. The shape of this insect is very interesting. So the head and the thorax happen to be of a harder material, whereas its abdomen, this whole area right here, is much thinner, and this is actually where it takes oxygen from the water and dissolves it through its skin in order to breathe. And then I wanted to include an adult version of this as well. So once it hatches, then it is then an adult form. Those pincers are crazy. All right, the last species that I wanted to talk about, an example was aquatic worms. Although Nate didn't quite highlight any of these, I wanted to at least show a species that belongs in group 3, so tolerant to pollution. Fun facts, they do not have any suckers or eyes, as well as they tend to live in lakes, ponds, streams, and wetlands. They're still a critical part of the environment and a great food source for other species. But they themselves tend to eat detritus. So if you haven't heard of that before, it's eating decomposing plants and ant materials, but they're also algivores. They like to eat algae. So now Ashley's going to actually launch a question that I would like you all to answer based on the information that I shared. I'll read it out loud. It says, benthic macroinvertebrates are used by scientists to monitor water quality. Is this a true statement or a false statement? We'll give everybody a little bit of time to answer, and then Ashley will show us the results. All right, so benthic macroinvertebrates are used by scientists to monitor water quality. The answer is yes, true. They are a great reason, again, because they live in the water, they give us direct contact, they're easy to capture, and they fall into different categories of can they handle pollution or not handle pollution, that tolerant and intolerant. Second question on my behalf. Which of these benthic macroinvertebrates is intolerant to pollution, meaning they cannot survive in polluted water? Is it roundworms, black fly larvae, stonefly nymph, or a clams/snails? All right, 91% of you got it correct. The correct answer is the stonefly nymph. It was the very first slide that I showed. Again, I said they belong to group 1, which was an intolerant to pollution category. So great job. With that, I'm going to press the next slide and I'm going to pass the floor over to Ashley to do the final conclusion portion of our presentation.
All right, so here is some exciting stuff. We are going to chat about basically what does this mean. So there's been a lot of awesome questions that have been coming into the Q&A box that Nate and I have been answering about some of these different species and where they can exist. And so if you look at the table that I have on the screen right now, I've got it organized, and this actually is a little bit more complicated than the chart that Caroline shared with you. This is more like what we would use out in the field if we were collecting this data for research. And so looking at this now, we have You'll see pollution tolerant group 1 on the far left with excellent water quality, and then all the way over to actually pollution tolerant group 4, which is going to indicate, those species indicate poor water quality. And so how this works, I've kind of coded everything here. This is actually the number of species that Nate found in that sample from the stream up in Saranac, and how many organisms were in each of those categories. If it's blank, it just means that there wasn't anything there. So if we go to the next slide, we've added another little component about this. So how this works, the pollution tolerance index is one way to take all of that data, all of those numbers, and make meaning out of it. And so to do this, what we do, we're actually looking not necessarily just at the number of species. So if we look at stonefly nymphs, you'll notice that there's 30 plus that we counted of various different stonefly species. So we're interested in that. That's really important. But what we really want to know is, see at the bottom here where it says taxa? So we're actually looking at the diversity. So how many organisms from group 1, pollution tolerant group 1 here, did we capture? And so you'll see that that number is 6. So that means if you were to count, we've got stonefly, mayfly, caddisfly, dobsonfly, riffle, beetle, and water penny. So that's going to be our number of taxa. And so I've done that for each of these categories. And so just to clarify, some of you were asking really great questions about, could organisms from group 3 or group 4 be in a really healthy stream? And the answer is yeah, totally. But those species from group 3 and 4, or from group 1 and 2, cannot be in a stream that has poor water quality. So that's kind of tricky. But the way that this works at the bottom is we then take the number of taxa and we actually multiply it by a weighted factor. So we're getting into a little bit of math here. And the idea is that we're trying to get a number. And so Caroline, if you want to go to the next slide, if we add up all of our weighted numbers after we did that multiplication, our pollution tolerance index rating is 28. And so Caroline, can you go back to that slide for one more second just to see that? So looking at the bottom here, you can see we took 24, we added 4, this column was a 0, so we just ignored it, this column was a 0, and then that gave us 28. So now if we look at our chart that actually kind of qualifies how many organisms we've found from those taxa into water quality, we can say, okay, we found 28 for our PT rating, a pollution tolerance index rating. Our number is 28. Using this chart to the right, what's our water quality for this stream? Can folks just pop that into the chat box? I'm just going to give you a quick 10 seconds to see if you can figure that out, and then I'll let you know if you're correct. What do we think? Is the water quality excellent, good, fair, or poor? Excellent. Yeah, Kate. Awesome. Lots of things coming in. Exactly. So the water quality for this is going to be excellent. And now to build off that, I'm going to launch a poll right now. So you can go ahead and actually, oh, hold on. This is not the right question. So I want to know from this list, what's your favorite benthic? And it doesn't necessarily have to be from group 1. You could choose something that is from the other groups as well. Just curious to see what folks are into. Awesome. So lots of people interested in crayfish. That's great. And so I'm going to actually just go right into our Q&A here and let you ask us some questions. I see that there's questions coming into the chat box right now for us. Oh, what is taxa? Let's answer this one live. Nate or Caroline, do one of you want to answer that question? Or?
Sure, I can. So taxa just refers to the way we group together organisms. So in this scenario, often that means the order, but it's a less specific way of saying order, family, or species. It just refers to a group of organisms that scientists have categorized together for some reason. So in this scenario, saying that group of taxa, that organism group, holds significance because they relate to pollution in a similar way. Hopefully that answers your question.
That's great. Yeah, and then another one came in about, are water pennies insects? They are technically aquatic beetles. Is that team. Is that correct?
That is correct. That's my understanding. Yep.
Yep. And then Nate, someone wants to know, what day were you out at the stream monitoring?
That was March 19th, if
Yep.
my memory serves correct. And due to my scattered life, I don't remember the day of the week, but I think that was last week around Thursday.
It was on Thursday.
Yeah.
All right, Ashley, maybe you want to do one more question, then I'm going to pass over the floor to Lauren,
Yep.
screen share-wise, since based on the time.
And yeah, and what I'll say is, since we're kind of wrapping up here, we didn't have a ton of time for Q&A. Type all of your questions into the Q&A, and we'll send a follow-up with all of the answers to this. Our team will go through and answer them for you. And so I'm just going to answer Evelyn's question real quick because it's a fast one. Are these found in all rivers? Yes, to some degree, depending on the pollution that is entering that stream and the water quality. So theoretically, even in really poorly polluted rivers, there are some aquatic worms and things like that living in there.
Great. I'm going to unshare the screen. Lauren, you should now have control.
And I'll just add, while we're transitioning, you'll have a second to jot down all of our emails, and I'll type mine into the chat right now. So if you have follow-up questions, feel free to reach out to us via email. We can answer.
So as we wrap up today, this was our very first virtual cafe, and we're going to ask 2 questions. Ashley, if you could launch the poll. These are anonymous, so just be honest. And then if you want to give any qualitative feedback to us, type some stuff in the chat box, because again, this was our first, and we are planning to do these every Wednesday. So your feedback to us is going to be very helpful. So go ahead, please answer questions 1 and 2, and let us know how you think, what the overall experience was today. The second question is about any knowledge that you gain. So 1 is poor, 5 is excellent. Please, everybody respond. The more feedback we get, the better we can learn from you. And then type in the chat box if there's anything you want to tell us about today. We're about halfway there. If you guys can keep answering. If for some reason you don't see the poll, just put stuff in the chat box. All right, looks like I'm gonna end the poll, so thank you for that. And what we want to let you guys know, we're going to be doing this every Wednesday while school is out. So we do have a cafe scheduled for next Wednesday on small satellite propulsion. Should be very cool. We have a space engineer who's going to join us. You can go to the website that is listed, and I believe Caroline's going to pop it in the chat box.
Ooh, yep, good call.
You can go ahead and register for that. You'll see we all already have a cafe topic for the April 8th and April 15th. So we hope that you will join us again, and we thank you all for coming to be a part of today. So thank you, and let's thank our presenters for helping to educate us about benthics. So appreciate you all. And with that, I think we will end today's cafe.
All right, and I just put the link in there, everybody. And Lauren, whenever we end here, somebody press the end recording button, please.
Great. Yeah, thanks everybody. I'm seeing a lot of specific comments about where to find some of the resources we use. That's a great thing to follow up with me individually. If you want to send me an email, I can direct you to some of those resources, like where to find dichotomous keys. But for a lot of that stuff, a quick Google search will produce some of that stuff.
Great.
Awesome. Thank you all so much. Have a great day.
Thanks for coming, everybody.
Thank you.